Good day, class. We are now in our second module entitled Soil Formation and Development. Let's start with Lesson 1, Soil Forming Rocks and Minerals. So we will be discussing mainly about rocks and minerals. Please be guided with our learning outcomes. You are expected to be able to define and discuss the differences between rocks and minerals, define igneous, sedimentary, and metamorphic rocks, especially on how these are formed, illustrate and discuss the rock cycle, discuss the mode of formation, texture, color, and acidity of igneous rocks, enumerate examples of igneous, sedimentary, and metamorphic rocks, and determine and define primary and secondary minerals after the Lesson 1 discussion. We can find rocks everywhere, but have you ever wondered how rocks are formed? Have you ever wondered what rocks are made of, where they came from, why we have smooth and rough rocks, why does we have black and white colored rocks, why they have various colors? Do you know that we have rocks that are considered acidic and basic? Why we have big rocks like human size or much? And why we have hand-sized rocks or smaller than that? It is very interesting because you will be able to answer those questions after this lesson. I also assume that you are familiar already with the three types of rocks. These are igneous, sedimentary, and metamorphic rocks. But which one do you think contains more nutrients? In this lesson, we will be learning a lot about rocks and minerals. May you ask why? Why should studying rocks and minerals included in studying soil? So, learn why. Let's start. First, let's define rocks and minerals. Rocks are naturally occurring. It is not a man-made, of course. It is formed due to natural processes. It is hard and composed of inorganic materials like minerals. It is composed of one or more minerals. While minerals are solid, not gas or liquid, it is inorganic, homogeneous, crystalline, and composed of one element or more than one, which is called compound. Here is an example to better understand and imagine the differences of the two terms. So we have here rock, specifically granite. This is granite. And granite is composed of minerals which are quartz, hornblende, and feldspar. Here is a simple illustration of the origin of the soil. Most of the materials that makes up the soil comes from rocks and minerals. This is now the reason why you have to study minerals and rocks in understanding the soil. These rocks and minerals are weathered in place or weathered and transported and become unconsolidated material on the surface of the earth. That material is called regolith. The upper part of regolith is soil. This unconsolidated material is acted on by the soil forming factors and soil is formed. For this reason, the upper part of the regolith is called parent material. So, the origin of the soil are rocks, which is basically composed of different minerals. With the soil forming factors and processes, it formed into soil. So, basically, that is the reason why we must understand rocks and minerals because in studying soil, because it is the origin of the soil, it is the parent material of the soil. So that's it. Examples of soil-forming rocks are basalt, andesite, obsidian, sandstone, shale, limestone, quartzite, slate, and marble. We have three types of rocks: igneous, sedimentary, and metamorphic rocks. Igneous rocks are formed from cooling of magma. Examples are granite, which are light-colored and coarse-grained, and basalt, which is dark-colored and fine-grained. So basically, granite and basalt are opposite. For sedimentary rocks, these are formed from deposition and compaction. We have three examples. We have shale. It may have any color and it is fine-grained. The sandstone also have any color but coarse-grained. The third example is limestone, which has light-colored, and shales or calcium carbonate are present since these rocks are usually formed near the sea and incorporated with debris from sea. In addition, limestone are light-colored because the characteristics of calcium carbonate is, in its appearance, it is white. The third rock is metamorphic rock, and it is not common. These are formed from the alteration of pre-existing rocks. Common examples are slate and marble. The slate may have any color and it is the hardened shale. So, a metamorphosized rock of shale is slate, while the marble also have any color and it is a changed limestone. So limestone undergone processes involving heat, stress, and pressure, and it is changed into marble. Types of rocks. Types of rocks. Igneous rocks. These are rocks formed from solidification of lava or magma. We have extrusive igneous rocks, which are forms at the interface or at the Earth's surface. It has a small mineral crystals. We have intrusive igneous rocks, forms below the Earth's surface, and it has larger mineral crystals. Take note that the faster the rate of cooling, the smaller the sizes of the mineral crystals are produced. Igneous rocks may be the most important of the three types because the other two forms are just the alterations or changes of igneous rocks. Second type is sedimentary rocks. It is formed by consolidation and lithification of sediments. Lithification is a process of sedimentary rock formation. Metamorphic rocks. Rocks formed from the alteration of pre-existing rocks due to heat, stress, and pressure. Let's discuss the rock cycle. In describing the rock cycle, we can start anywhere we like, although it's very convenient or it is very common to start with magma. Magma is the rock that is hot to the point of being entirely molten. This happens at between about 800 degrees and 1300 degrees Celsius, depending on the composition and the pressure onto the surface, and it cools quickly, just within seconds or 2 years, forming extrusive igneous rocks. In rock cycle, any rock can become any other rock, depending on what processes or path it takes. Igneous and metamorphic rocks may weather and form sediments that are deposited and lithified, then later on become a sedimentary rock. The flow of magma through pre-existing igneous or sedimentary rock give rise to metamorphic rock. The rock cycle allows us to visualize the interrelationships among different parts of the Earth system. It helps us understand the origin of igneous, sedimentary, and metamorphic rocks, and visualize that each type is linked to the others by earth processes. That is why it is called as cycle. Let's move on. We have two types of igneous rocks based on the mode of formation. These are intrusive and extrusive igneous rocks. Intrusive or plutonic are formed when magma solidifies or crystallizes underneath or at the very great depths. Take note of the term intrusive from the word internal. Examples of these are granite and gabbro, which has a larger grains compared to extrusive igneous rocks. Okay, while the extrusive or volcanic igneous rocks are formed from the solidification of lava or any volcanic debris. Take note, extrusive from the word external. Examples are basalt and andesite. As what you can observe, basalt and andesite has smaller crystals or grains compared to granite and gabbro. Why? It is because of the rate of cooling. When the lava are exposed to the Earth's surface, here, the temperature changes, that the cooling or crystallization are faster, that leads to have a small grains or crystals. Take note that the faster the cooling process is, the smaller crystals are produced. This photo shows the differences of intrusive and extrusive rocks. The magma crystallized underneath intrusive rocks, while the lava and other volcanic debris form extrusive rocks. Next, different types of igneous rock textures. This is the second property for igneous rock, texture. Texture describes the overall appearance of a rock based on size, shape, and arrangement of mineral grains. There are factors that influence the texture. First is the rate of cooling. Slow rate cooling process produced fewer but larger crystals, while fast rate of cooling produces many small crystals. Second is amount of silica, and the third one is amount of dissolved gases. We have 7 types of igneous rock. We have aphanetic, phaneretic, porphyritic, vesicular texture, glassy texture, pyroclastic, and pegmatitic. When we see aphanetic, it is fine-grained texture, which forms with rapid rate of cooling, and therefore there is a microscopic crystals. That is why it is fine-grained texture, aphanetic. The second one is opposite to aphanetic. The term is phaneretic. It is coarse-grained texture. It is formed with slow cooling. It has a large and visible crystals. Coarse-grained texture, phaneretic. The third one is porphyritic texture. There is a large crystals or called phenocryst, which are embedded in a matrix of smaller crystals, which is named as groundmass. There is a mixture of coarse and fine crystals, probably results from two-step cooling. The fourth one is vesicular texture. The rocks contain voids left by gas bubbles in the lava. This is a common feature or a common texture of an extrusive igneous rock. This is an example. There is voids in the rock. It is due to the bubbles. Okay. The example of this is pumice. There is voids. Okay, vesicular texture. The fifth one is The fifth one is glassy texture.